Hello and welcome to another math video. In this video we are going to be continuing our work on our FSTA final study guide, starting with problem number 44, and the plan is to work through number 55. So in 44 we are finding the product of these two polynomials. We've got one polynomial that has 4 terms and the other one has 2. So what I would do would be to set up kind of a short wide box here. 1, 2, 3 lines, break that up into 4, and then I can put the 2x plus the 3 here, and the 3x cubed minus x squared plus the 4x minus 1 there. And then we just go through and find our different products, and then once that's done we'll combine our like terms. So we get a 6 x to the 4th minus a 2x cubed. We get a positive 8x squared and a minus 2x. So just like that, we're halfway through. We got a 9x cubed minus 3x squared. We got 12x. We got minus 3. We do have some like terms there. Highest degree term is 6x to the 4th. That's the only x to the 4th term. Got a 9x cubed and a minus 2x cubed, so that's a plus 7x cubed when we combine those. A minus 3x squared and a plus 8x squared, so that's plus 5x squared. 12x minus 2x would be 10x, and then minus 3. So, of course, you could use some other methods. Foiling doesn't work at all. Really, you could use the basic distributive property, but that's 8 things to keep track of, so that's where I highly recommend making use of that box. 45 is a special pattern. You don't have to use the special pattern. I would recommend it. You could box this or FOIL it if you wanted to. This is the sum and difference pattern, though. What this tells us is that all we have to do is square the 8r and then square the 5, and it's going to be the difference there. So that'll give us 64r squared minus 25. So pretty slick when you know that pattern. 46, squaring a binomial. Again, you don't have to use the pattern. I'll show you what the pattern looks like. I'm jumping into the wrong side of that. A plus b squared. So we square a, we add 2ab, and we square b. Now, again, of course, the problem people have with this is they will square the first term, they will square the last term, and they will forget that they get this product doubled in the middle. Again, what happens there is you're multiplying 5m plus 12 by 5m plus 12. So you have a 5m times a 12 and a 12 times a 5m. You have that twice. What people mistakenly do is they try to distribute that exponent, but exponents do not distribute over addition or subtraction. Exponents do, however, distribute over multiplication and division. Anyhow, so if we were to square the first term and take double the product of the 2 terms and then square the last term, let's put that in parentheses too. So we get 25m squared plus, this would be 60m, double that, we're talking 120m. 12 squared is 144. There we go, that's what we get when we have that. Switching gears a little bit to division. Now with 47, we're dividing by just that monomial, so all we have to do, divide each of those terms individually by the negative 6x cubed. There are different ways you could deal with these negatives. I like this way, obviously that's why I'm doing it that way. So the negatives all cancel out here. 48 times 6 is 8. That does not look like an 8. X to the 4th over x cubed would be a plain x. Here the x cubes cancel. Negative 30 divided by negative 6 is 5. Here the x's actually end up in the denominator. And negative 36 divided by, oops, forgot my negative there. Negative 6 is a positive 6. So we get 6 over x for that. Looks like that. And then we're going to change gears a little bit again here, switching to angles. Finding a complement of an angle whose measure is 36 degrees 16 minutes. So complementary, oops, get my pen back here. Complementary angles add up to 90. So really what we would do would be 90 degrees minus the 36 degrees 16 minutes. Trouble with that then is I don't have any minutes to subtract the 16 from. So what I do with that is I borrow one of the degrees, making it 89 degrees, and exchange that or turn it into minutes. Then I have degrees and minutes that I can subtract this from. So 60 minus the 16, we're talking 44 minutes, and then 89 minus 36, you're talking 53 degrees. So 53 degrees, 44 minutes. You can check that by making sure that that makes sense, that if we add 53 degrees, 44 minutes to 36 degrees, 16 minutes, that we actually do get 90 degrees. So you can check that. 50, same sort of thing, goes a little bit further though, and make sure you notice we are talking about supplements, which those are 180 degrees. So since we're looking for a supplement to an angle that has degrees, minutes, and seconds, we would convert that 180 degrees to 179 degrees, and then we would have 60 minutes, but we're going to borrow one of those minutes, just like we borrowed one of the degrees, and we're going to change that into 60 seconds. So, see, that symbol looks a little funny there. Fix that up here. So again, the way that works is the 60 seconds, that's a minute. So we add that in here, that's really 60 minutes. 60 minutes is really a degree, we add that there, we get 180 degrees. And so we just subtract from that the 37 degrees, 33 minutes, and 29 seconds. So we get 31 seconds, let's see, 26 minutes, and 142 degrees. Again, does not hurt to check and make sure that if we add those together, we actually do get 180 degrees. Number 51, then, they give us expressions for a couple of angles, 3x plus 8 and 2x minus 3. They tell us those are supplementary. Well, if they're supplementary, that means that when we add those together, parentheses for emphasis, that the sum is 180 degrees. So all we have to look at there is that we would have really, let's see, that would be 5x plus 5 would equal 180. Subtract the 5, that's a 5. We get 5x equals 175, and divide by the 5, we find out that x is 55. Now, again, if this is multiple choice, they may have 55 as an option, because sometimes people forget that finding x wasn't the objective here. Getting the actual angle measures is the objective. So we plug that 55 back in. I might plug it in here, actually. So 2 times 55 minus 3, so 110 minus 3, we're talking 107. Well, so no, okay. Boy, good thing I'm paying attention here. That's not 55. That should actually be 35. I don't know what I was thinking. Okay, so let's erase that. You were probably thinking, what's he doing? Yeah, I was making a mistake. Okay, but I knew it didn't add up, so that's how I caught myself here. Okay, so that's 35. So that's not 110 or 107. This would be 70 minus 3, which would be 67. Okay, just because I already made a mistake, I better check the other one as well. 3 times 35 plus 8. So it'll be 105 plus 8. Okay, so 113. That does make sense. So the two angles being 67 degrees and 113 degrees does make sense, because those do then add up to 180 degrees. So yeah, be careful, don't do silly stuff like I just did. Let's see, I just about skipped 50. All right, okay, I got 51 here. Okay. All right, and now we'll go back to number 48. So with this one, I'm going to start by using long division. You could use synthetic if you know that. I know in my class specifically we spent more time with long division just because you need that for things where synthetic doesn't work, although synthetic would work here. Let me fix that quick. So we've got our divisor x plus 6. We've got our dividend x squared plus 11x plus 30. And we've got a three-step process that we go through. So we start by dividing that first term of the dividend, in this case x squared, by the first term of the divisor, in this case that's x, and we get x as the result. So that's the first part of our quotient From there, we need to find the product of x and x plus 6. In this case, we get x squared plus 6x. Now, the next part is where people tend to struggle or have issues, and this is how I kind of deal with that. So I can see my x squared plus 6x, they have the same sign. They're both positive. I need to subtract those, so I end up subtracting both the x squared and the 6x. So I kind of just distribute that subtraction through before I even write those down. That helps get rid of any kind of confusion about whether I'm adding or subtracting. So the x squareds, by design, those cancel out. I get 11x minus 6x, which gives me 5x. In this case, I get 5x plus 30. We start our process over again, so now I've got the 5x divided by x, which gives me 5. And I need to find the product of 5 and x plus 6. In this case, it is 5x plus 30. Again, notice they have the same sign, and that's going to be the same way throughout this entire problem because the x plus 6, those have the same sign. So I have to subtract that 5x and subtract that 30. Again, they're both going to be subtracting because they have to be the same thing, either both adding or both subtracting. In this case, everything cancels out and I just get 0 as the remainder. And so the answer really is that quotient of x plus 5. I don't know why I put that in parentheses, but that's the answer. So x squared plus 7x plus 30 divided by x plus 6 is x plus 5. Real quickly, if you want to see what synthetic division looks like for that one, we take our x plus 6 and we do a negative 6 here. What that does is allows us to add the whole time. Then we take the coefficients of our dividend, the x squared plus 11x plus 30, the 1, 11, and 30 there, and we drop the 1 down, multiply the 1 by negative 6, add the 11 and negative 6 together, multiply the 5 by negative 6, and then add the 30 and negative 30 together to get 0. Again, it started off as an x squared here, so this is 1 degree less. So that's a 1x plus a 5 with a remainder of 0 there. So if you remember how to do synthetic division, great. You can use it on a problem like that one. Otherwise, you can go ahead and stick with long division. That's perfectly fine as well. I just need to come up to the top here. There we go. I lost 52 there for a second. All right. So 52, we are converting the angle to decimal degrees around to the nearest hundredth of a degree. You can actually do this on your calculator if you know how. You just type that in, and as degrees, minutes, and seconds, hit enter. It should automatically convert that to degrees for you. But I want to talk about how to do this by hand. So what we want to do here is divide the 58 by 60. That will convert those seconds to minutes. Now this is approximately 0.96 or 97, but that's repeating. So what I'm going to do is I'm going to add that to the 15. So that's not going to do much other than change that from a 0.96 to a 15.96. So on my calculator, I'm just going to go plus 15. So I got that 15.96. And then what I do to that is I divide that by 60. 15.96, repeating, divide by 60. Divide that by 60. That's going to convert those minutes to degrees. Now that is, I guess I can use an equal sign there since I didn't actually approximate. That equals 0.2661 with the 1 appears to be repeating there. Now what I do is I add that to the 43 degrees that I already had, but again, that doesn't do anything really here besides changing that from a 0 to a 43. And they do say to round to the nearest hundredth, so that's 2 decimal places, so it'd be 43.27 degrees would be what we're looking at. So really just dividing by 60 and adding to what we have. Converting to degrees, minutes, and seconds, boy, at 87.99 degrees, that seems like it's basically 88. So what we do is basically the same as what we had before, but we kind of do that in reverse. So we're going to multiply the 0.99 by 60. So 0.99 times 60, that's 59.4. So and that's exact, 59.4. So that would be 59.4 minutes. So that tells us it's 87 degrees, 59 minutes. And then we multiply the 0.4 by 60, and we get 24. So that's 24 seconds. So 87 degrees, 59 minutes, 24 seconds is what we're looking at. And again, I didn't have to round anything at all there. Finding the angle of smallest possible measure that's coterminal with the given angle. So what that is really saying is find an angle between 0 and 360 degrees that's coterminal to that one. Well, angles are coterminal if they are 360 degrees apart or multiples of 360. So what I look at there with the 884 is that is over 720, which is 2 full revolutions. So I'm going to do 884 minus 720 to get 164 degrees. That tells me that, yeah, those are coterminal. The 164 is between 0 and 360 like we want. Now an angle like a negative 88, that's a negative angle, that's less than 0, so we add 360 to make that between 0 and 360, we get 272 degrees. Again, between 0 and 360 like we want. That's how we do that. And again, with other things you might change how much you add or subtract, but it's always going to be multiples of 360. Well, as always, thank you for watching, and hopefully you found this video to be helpful.